now, isn't it? Okay. Well, at least the last question we do won't have an echo. Okay. So here we have, it says, determine the mass defect and binding energy of beryllium-9. And then it gives us a bunch of values here. Okay. So beryllium-9. Beryllium-9, you check your periodic table, has an atomic number of 4. So this is going to take some chemistry, like some grade 9 chemistry here. 4 tells us the number of protons. For a neutral atom, it is also the number of electrons. And then we take our mass number, subtract our atomic number, and we get the number of neutrons. All right, so let's just figure out what the total mass is if we add up all of these together. So 4 protons. So we have a mass of 4 times the mass of a proton. That U is atomic mass units. They give us the conversion here into kilograms, but we'll do that later. So 4 times 1.007276 U. For the electron, that's 4 electrons. So 4 times, here is our mass of an electron, very small, 0.000549 U. And finally, we have 5 neutrons, so 5 times, here's our neutron, 1.008665 U. All right, so if we add all of those together, we get a total mass of 9.0746601 U. Notice that this mass is bigger than the mass of the atom that it actually makes up. And so when all of these particles come together, they fall to a lower energy state. And as we know, energy and mass are related. Okay, so we can figure out the difference in mass, and that is our mass defect. So if we do that, we take this one, and we'll subtract the mass of the beryllium atom. So we have 9.012183. We get a mass defect of 0.062418 atomic mass units. And that is, if you wanted to completely break that atom apart, the amount of energy that would be required to do so. So that's our binding energy. And we can calculate that with this wonderful equation here. So we put in our mass. We are going to have to change that into kilograms. So we're going to do that now. We'll use that conversion. So multiply by 1.66 times 10 to the minus 27. Oh, got a comment. Hey, just saying hello. Kilograms per atomic mass unit. And then sort of ran out of room, but multiply by the speed of light, which is 3.00 times 10 to the 8 meters per second squared. And when we do that, we get our binding energy, which is 9.33 times 10 to the minus 12 joules. Okay. That was the last question I wanted to go over. I hope that helped a bit. Sorry for all of the echoing in the beginning of the video. Now that I know what the issue is, I'll make sure in my other live sessions that won't happen. Does anyone have any questions before I finish? All right then. If you think of a question later, you could put it in the comments, and have a good evening, everyone.